So today's topic for our Technical Camping webinar for Europe, I did run this in DACH in German already, so now in English for all the other European countries. Today's topic is Edge Security Pack, specific on OIDC, what that is. And the second topic will be how to balance LDAP. What options does the load balancer product offer there, and how is it done? So let's start with our topic on OIDC today. OIDC is part of the OpenID Connect protocol landscape. It's a lightweight or lighter version of SAML, and it allows you to do multi-factor authentication against Azure and also some other identity providers, but so far we support Azure. When it was released, they promised to me that we will add more identity providers to it. So that will happen. It just didn't happen so far yet. So maybe we get Google Suite or Ping Identity or Okta or anything in there as well. Right now it's limited to Azure. It allows you to do multi-factor authentication based on the settings that you have set in Azure. And you can create a single sign-on along with other applications that might not be handled from the load balancer side. And that way you make sure that you don't have too many authentication prompts for your users, which is pretty good. How does it work? The load balancer will receive the initial request for the application. It will realize, hey, pre-authorization is needed. There's no cookie for that or no authentication cookie for that person yet, and will redirect to the identity provider, which is the cloud in this case. And there the authentication will take place, and the client will be redirected after successful authentication to the load balancer with a token, and the load balancer then will verify the token with the identity provider to make sure that's all correct. And once that is verified, the access to the application is granted. So the load balancer here in this case is more the resource server. Authentication happens in the cloud. After verification, access to the resource is given. I also use a different method. I hope this is a bit better to understand. So the client request comes, we redirect to the authentication provider. The whole signing and authentication happens there, and with the authorization code back to the user, they can come back to the load balancer with that, and then we can continue on. Now, I've marked it here because the load balancer is not part of your domain. It's not connected to Azure either. It never has the password here in this case. So we only have the username and authorization code we got from Azure. That means we cannot fill out basic authentication to the backend or form-based authentication to the backend because we never had the password in the first place. So what we can do is either send nothing to the backend or create a Kerberos constraint delegation ticket and pass that on to the backend. So that's what I've shown here. In your Azure portal, to set this up, you need to register your application first, and there you can decide, should it only be for a specific users, should be for the whole AD directory, or should it even include non-AD directory accounts like normal Microsoft accounts, or should it only be personal accounts that are allowed to go to this application. Once you have the application registered, it looks like this. So you see your application is registered. You have point for endpoints here. You see their application ID. And what you need to do is you need to add a redirect URI. So a direct URL where after successful authentication, the client should be sent back to. Without that, it you never make the return to the load balancer or to the application you wanted to open in the first place. Also, you need to generate a secret. Here we go. You need to create a secret and be quick to copy the value when it's generated, because the value will be coded after a minute or two, and then you can't copy it anymore. So you need to be quick. Once you generate the secret, you need to be quick to copy it out. Otherwise, it will disappear and you need to create a new one because you can't reclaim it afterwards. When you go to endpoints, you get all the links and all the details you need to fill out on the load balancer as well. So you see the authorization endpoint, token endpoint. You can decide if you want to use version 2 or version 1, both works. And on the load balancer, you get asked for those information. So which application is it with the ID, endpoint, token endpoint, and the logoff URL. I always send the person to portal azure.com sign out. That works for me totally fine. I think now on the newer version, you have one row here in top, but I didn't mention it yet because those things are vital for it to work. The new line that you got here in the newer versions is self-explaining, but not mandatory. So once you have assigned one of your virtual services to use OIDC, you will be redirected to loginmicrosoftonline.com to log in. And here in this case, it was a colleague of mine who had his account then to choose from. And once that is happening, based on the Azure setup, the MFA and stuff will kick in. Once you're authenticated, so here in this case, it's just simple user with password. It will ask you if you want to stay in, and once you confirm that, you get redirected back to the load balancer, but with the authentication cookie and everything. So here you see that was at the time, years ago, that was the web page on our application. You got redirected to. Once we have the generated code came back from Azure, we verified that. And once that is all fine, you get a load balancer authentication cookie to go through the application. In your sessions for your SSO manager, you will see the user that logged in. You see what source the user came from and where he went and when he authenticated. And did I go forward or backward? No, that's interesting. And when you log off, you get sent to the portal.azure page again. In your ESP logs, it looks like that. So these are the user logs. So you see the OIDC was used. The person was using this application, was authenticated. So you see the response from Azure that he was successfully authenticated has been verified. And once that has happened, you see that the GET request for that user went through and they are authenticated. If you want to see it even more detailed, the SSO manager debug traces allow you to look into it as well, even a bit further though. So you see that the redirect happened to Azure. Then you see that they come back with a data token that was verified. And once that was verified, you see here, OIDC was verified and okay. And then the LM data cookie was generated. So here it was different. I mean, I copied a bit much. Here was one verification failure is in as well. So you can, in the SSO manager debug traces, you can troubleshoot if there's something wrong with the OIDC as well. I copied a bit more in here. Now for the logoff, you can also use the SSO manager debug trace to go deeper into it. So you see that the person or the client user was logging out, and that was triggered in the load balancer to find the person, and you see here that the token has been removed. So now once the same user is trying to log in again, they will have to re-authenticate. If the secret between load balancer and Azure is not correct, you might run into an error looking like that. And if you have not put in the redirect in the Azure portal that I mentioned earlier, you get an error like that. So you have authenticated properly, but it cannot send you back to the application because the redirect wasn't there. So these are, two errors I run into while I was setting it up, and I thought I share this with you. And this will be the demo. But having said that, because both of our topics are very close together, I will put the demo in one big demo later on. So for now, we go through the theory part, but later on I will show you what it would look like to log in with form-based using LDAP. And I also show you how it looks like to log in with OIDC and even use Kerberos going to the application. Now, for the LDAP part, I hope there are no questions so far that I have missed, maybe. No, doesn't look like it.
Yes, there's one question, Renar.
Okay, so the chat was empty. Where do I have the question field? Give me a sec. Oh, here we go. There we go. I haven't had it open. So, bonjour. Yeah, that's good. Did you ever test it pre-auth auth 2 with Exchange MAPI on Outlook? Danya, I don't know why you would do auth 2 with MAPI, because that actually makes no sense, because the MAPI protocol doesn't give you a login form. And Microsoft has enabled modern auth for all the Exchange protocols except OA and ECP. So I would not even go with auth 2 on MAPI. I would just use modern auth that Exchange brings naturally. So you are better off with that than using OAuth 2, to be honest. But yeah, I understand your point, but the thing, MAPI, you can do basic, yes, and you can do NTLM. But other than that, Outlook doesn't give you any form to enter stuff. So then I would rather go with modern auth. And so then you don't need to worry about ESP on the load balancer for that. To answer that question, I just answered the question for everyone, so that should be good. Cool. Now, LDAP. Oh, sorry. LDAP load balancing. So first of all, we need to talk about what LDAP is. So in general, we have two different things we can do with LDAP on the load balancer. Okay, so that is first of all, we can create a virtual service that can balance LDAP for us. So you can create a VIP, here in this case on LDAP S 636. It needs to be a generic type. It's not HTTP, obviously, so it needs to be a generic type. You have server initiating protocols, other server initiating. SSL can be turned off, but technically you can also turn it on and even re-encrypt or offload if you want. So I have built a VIP where I come in with 636, but I continue with 389. So you can even offload from LDAP S to LDAP if you want to. And for LDAP S, you need to use TCP connection only as a health check. For the normal unencrypted LDAP protocols, you can do LDAP endpoint to do a check with a bind request. So I kind of broke it down here for LDAP. It's generic, other initiating, SSL, off, and you can do the LDAP endpoint for the health check if you want. And for the S, so for the secured options, the only difference is that you need to do the TCP check. So that's when you build a VIP to balance LDAP requests to your application servers. On top of that, the load balancer also has the LDAP endpoint. So this is used for the load balancer to do the LDAP request to authenticate a user for an application, or maybe even a user to go into the management of the load balancer in the first place, right? So anything the load balancer needs to authenticate users, request group memberships, and so on, we need the LDAP endpoint for that. So the way that works is you can have up to 3 LDAP servers listed here on the top line, space separated. Then you select the protocol, either LDAP, so unencrypted, or LDAP-S encrypted. And I think you also have a start TLS option, but to be honest, yeah, if you can do unencrypted or encrypted, yeah, I'm not such a fan of the start TLS, to be honest. You can do a verification interval and referral count. So that means, is your endpoint here allowed to refer the request to another one? So you can set those settings there. And then it's asking for user that is used with a password to do the bind request to see if the applications, if the LDAP server is healthy in the first place. Why does the product management set the name admin user? I can explain that. In the Windows world, any user is allowed to do a bind request for another user, and is even allowed to, by default, to do a group membership request. But on a Linux radius, on a Linux LDAP, my bad, that is a specific right. Okay, that's not by default a right people have. So that's why they decided to put admin user there to make sure that the rights are granted for the user here to also be able to do group membership requests for other members. But a normal user, if you are in the Windows world, a normal user would do. Now, and when you use LDAP endpoint for health check, these credentials are used then in your VIP to do the health check to the LDAP systems behind. Okay, so that's what that is about. Now, you can also use the global catalog if you add colon and the port of the catalog behind as well, then the catalog will be used. Of course, there's a normal catalog unencrypted, 3268, and there's a catalog secured, which is 3269. Just to be aware of that as well. Now, instead of your direct server, for example, if you have a company or a customer that has 20 LDAP servers, right? If I'm saying here this is limited to 3, then I can't ask all 20 of them. So that's a pity. But what you can do here is you can put the VIP IP of the VIP you have built, so the ones you build here, the VIP IP, and here you can have 20 LDAP servers to stay behind. So that's possible to do it that way. Good. I also added a few links for that to give you some more information on how to create a service for that, how to load balance LDAP services, how to configure it with the endpoint, and even use start TLS as well. And now we get to the demo. That's the part I like most on those webinars, that I'm not just talk theory, but also demo this live. So, where is my little sleepyhead? Here we go. Good. Now, I do have a load balancer here on the latest GA release, and I have a few test services here as well. And now let's go through those VIPs that I built here for you. So you see here, down here, these are all LDAP examples. So I have a normal unencrypted 389 service to go to my domain controller. This is a test lab, okay? So I only have one domain controller in this lab. So otherwise I would have shown you the balancing of multiple, but this lab only has one. So I hope you can excuse for that. So 389 for this VIP, it's a generic. I even have normal protocols here, but you should use other server initiating. And there's no SSL, and the LDAP endpoint takes already the username and password from my LDAP endpoint for the health check. So that means I can use this VIP also for my LDAP request, and I can do my bind request using this. Similar is 636. So that's now a secured version of LDAP, LDAP-S. Was not thorough. Wow. So as a server initiating, you can enable SSL and re-encrypt, or you offload and go to 389, then offload it, entering 636, but offload it to the backend system. That's possible. But if you go secure to the backend system, make sure your health check is set to TCP. And global catalog is similar. So here in this case, I have the global catalog port open. That makes no sense. So this is unencrypted 3268. And I continue here in this case even to the normal LDAP point, but I could have used the same port as well, going to the global catalog port too. We can actually, let me think, yeah, we can add the server again to have two servers behind. That's nice. Here we go. So I'm able to go either to the normal LDAP port or to the global catalog port with this. So that's what a VIP would look like for global catalog. And for global catalog S, that's this one here. Sorry. You can do the same thing. You come in with 3269, and you can either continue with 636 or with global catalog S port as well, like now. So both of those options are fine. And if you enable SSL, you need to make sure you re-encrypt if you want to continue with a secure port to the backend as well. So it's no rocket science, to be honest, very straightforward. We also have templates for that, but those settings are pretty easy. Yes. And now, if you have more than one server behind, something to look out for, what I would recommend, I would add a persistence, even if it's just a source IP in a few minutes. That's just something I would do to make sure if there's a longer request or multiple requests from one source, that it goes to the same server. So I would enter persistence options. That's just me. I'm very interested in those things. Now we do have a question. Danielle, let me read it out so everyone can hear. I don't know very well Kemp LoadMaster, even if we have a couple of them. Can be set up the Kemp LoadMaster with an HA configuration. I mean, we would move to LDAP balancing, but a single load can be a single point of failure, isn't it? Yes, Danielle, it's not today's topic, but look up here on the top. You see there's two green boxes, right? One is without a letter, the other one is with a letter. So that has the letter A in here for active. So you ask for active passive, and this is exactly what I've done here. I do have a pair, one active, one passive working here. So yes, I have no single point of failure because I have two load balancers working actively together. So you can even see that I have a first and a second unit, and in the network setups, you see that there's unit 2, unit 1, and one IP address they both share. This is the one I'm connected on right now. So yes, it's HA. Off topic, there's another question from Simon. Are there examples of using auth providers such as Auth0? Not too sure what you mean with Auth0, but how about I show you all options that we have. So Simon, let's use you as a name. The authentication providers you can use are as follows. There's LDAP in all variations. There's Radius, RSA Secure ID. You can use client certificates, but that's with also with LDAP to connect or to verify the information from the certificate against LDAP. You can use a combination, Radius and LDAP together, or RSA Secure ID and LDAP together. We call this dual factor because you have two different authentication providers you ask simultaneously. We can do SAML using ADFS or Azure if you want. And you can use the light version of SAML, which is OAuth, OIDC, which works on version 1 and version 2. So these are the options to select authentication providers. I hope that answers your question. Good. Now, I did show you how to create a virtual service for LDAP. Now, Simon is back. I'm aware of those options. I was wondering if there's any example. Let me pause the question till later on, Simon. Otherwise, I'm not get through with the demonstration right now. But we can take that then at a later stage. So, creating a VIP to balance LDAP requests is one thing. The other thing is you can create an LDAP endpoint in your load balancer to make sure the load balancer is allowed or able to authenticate users logging in here, right? So I have now created an endpoint going directly to my domain controller, but I can also use here, for example, my VIP instead. So let's change this to the VIP address. Now I'm using the VIP address as my LDAP server. I can add up to 3 here, space separated. So I used unencrypted, so that's 389. And I have an LDAP user set and a password set. Now this LDAP endpoint I can use, for example, for an LDAP SSO domain to do form-based authentication, right? And I can also use that to log into the load balancer with a user group to do access to the load balancer, right? So that's something, let me just demo this here. If I go to my standby unit, hopefully I'm not making a fool of myself now. I hope I did create the group. Yeah. Great. So that didn't work. Awesome. I might not have created that that group yet. So let's check that out. Yeah, I needed to rebuild all of this lab yesterday because I was asked to show something different, but that was too short notice. Yeah, so it didn't work, obviously, because that user group I mentioned doesn't exist here. So let's create this quickly. And then I can demo this also to you because it's part of this setup today. But that means it did what it's supposed to do. If you're not member of the group, because the group doesn't exist, it should not let you in, right? So was exactly what was supposed to happen. So I've set this group called LM admin here, and only the admin was supposed to be in there, but it has not been created. So pity. Now let's do this quickly. There we go. So now the group exists and the person is in there. And let's try this again. And now I'm logged in with my domain user for my domain. It's the administrator, and he's now logged into the system. So great. When we have a look into the message log files for that unit, the first attempt, just check this here. The first attempt, you see the user was blocked because he was not part of the group. Obviously, if the group doesn't exist, then that makes sense. And you see here, now the access was granted because the person, the administrator, was part of this group, and the group has the permission of root rights, so all the rights and everything to be seen. So the LDAP endpoint can be used to log into the load balancer when you set it that way, but it can also be used for an SSO domain like my one here with LDAP. Okay, good. Now, no new questions. That's good. So we can continue. I have an application called webprogressdemo.com, and you see here it asks me for authentication. So just to show you what this is doing, it's this beauty here. It's a simple application. You come in with 443, you continue unencrypted, and authentication is on. You need to pre-authenticate in order to get passed on. So it's form-based to form-based. Why am I showing you form-based? Because I wanted to show you how the LDAP endpoint works. So the LDAPprogressdemo.com is my SSO domain. It has our endpoint in there. And when you log in, for example, with user 1, yeah, that was me not putting the backslash here. Then you see the application in the backend, and you see I got authenticated. I got a new LM data cookie. The username was user1, so that's correct. And on the load balancer, you see in Manage SSO, for this LDAP check, we got authenticated. And when we look into the to the ESP logs, I personally like those user logs very much. You can also see that user 1 has been authenticated. That was the VIP we were using. We used LDAP. Oh, by the way, that's not right. That's not right. The VIP was this one, 51. Here we go, 151. But the server we got authenticated on, that was our LDAP server. That's 153. If you remember, 153 is also a VIP of ours. So we were using this one here as our LDAP server, which was then going to the correct LDAP server in the backend, right? So that's what the log is telling us. And it tells us it was successful, and afterwards we get the information the user has logged in from this machine and went to this source with that user agent. So pretty nice log, to be honest, to see that authentication. So now you've seen the authentication work. Let's log off. Yep, I was already in the Exchange world. So when I log off, I see the logout prompt, and now my cookie is deleted. So now if I try to log in again, I will be prompted with authentication request again. And on the load balancer, you see there's no user logged in anymore. And even in our user logs, you see the person has logged out and the session and the cookie was deleted. Now, I think that's enough for LDAP right now. So let's look into the OIDC part. For the OIDC, I thought I'm going to do something that people are having issues right now and a little bit of trouble and so on, even though we had already a question about Exchange, so why not jump to Exchange? You might have noticed here, I was a bit naughty. I used the normal Exchange template and I've put my Exchange server behind, but as you can see here, there are two services called OAuth. There's one here, there's one there. There's also two services called authentication proxy, one there and one here. Now, I played with content switching a little bit. If you are logging in from Chrome, you will get a form-based prompt, normal form-based authentication for OAuth. But if you log in from Edge, and you could have used something else, you could have used an IP address to differentiate or something like that, that's no problem. But if I now come from Edge, I don't get the form-based. I should not have gotten the form-based form. What is this? That's a different redirector. It was working so nicely. Let me show you from here. Gosh. Try this again. Yeah. So you see now I was redirected to Azure, and Azure asked me for authentication. So of course this is my progress, my work account. I now need to log in, and what I did here was even more bad or even worse. Let's say it that way. I did create my domain here is called progressdemo.com, right? I created a user here, which is my work account, and I have a trust to the progress.com domain as well. So even though my normal domain is progressdemo, I created a user here with a progress.com account, just because that way I'm allowed to create a Kerberos ticket. As said early on, we can't fill out form-based to the backend if we're using OIDC. So in this case here, I have a local account created with a progress.com email, just because now with the Windows 2000 nomination here that I can create a Kerberos ticket for that user. So I'm logging in with my normal work account now. Here we go. It will ask me for the password, obviously, and it's right too. And now Azure comes with its multi-factor authentication, prompting me on my phone that I need to authenticate. At least it should. Come on. You're so slow. Come on. Normally the Microsoft authentication app is prompting me. Here we go. It just took some time. And now I need to enter that number that's written here. And once I have confirmed that, even with fingerprint and so on, then it asks me if I want to stay in. No, I don't. And it should redirect me back. Now, why hasn't it brought me back to my Outlook app? Because I have the wrong redirect URL in. And that's what I wanted to show you. You need to make sure to enter the right redirect URL in Azure to make sure this journey goes. So let me see if I can quickly fake it. Yes, I can. So now the load balancer got the data package with the authentication, went back to Azure, verified that, and created a Kerberos ticket to authenticate me against my Exchange server, so I didn't need to log in again. Pretty nice. And if you see that you see now I'm logged in with my progress.com account, even though my domain here for my Exchange is progressdemo.com. You see I'm logged in, and when we look into the logs, even here, you see that user with a Progress Demo account, with a Progress.com account has logged in for this request. OIDC was verified, and you see the person went to OA here in this case, to OWA in this case. And when we log out, let's do this. Unfortunately, that's something Microsoft has mangled up in, I think, CU 9 or 10, 2013. They got rid of the lockoff strings. When you go, the lockoff string only exists in form-based at the moment. So when you use Kerberos or Basic, you get something like this, but you won't be locked out. So that's a pity. There's a way of manually adding it, but with every Exchange update, it will be messed up again. So I'm not a fan of Kerberos going to the Exchange server because Microsoft, I don't know what they're smoking, but they messed this up. So I personally still think form-based is nice, but if you want single sign-on and you have everything with OIDC anyway, this would be your way. And if the lockoff string would be triggered, as you see, you get locked out of Exchange again. Here in this case, as I'm now logged in to Azure anyway, I get now into my Azure account. But yeah, that's that part. Now, Dania, you said excellent content. Great. I'm happy you like it. Now, yeah, no question, but a remark. This Microsoft login with KCD to an Exchange server is really cool. Much easier than hybrid modern auth at the first sight. You're right. That's why I showed it to you because I thought it's an option. So you can do this now with KCD to the server. And that's why I thought it's a good thing to show you that. That was actually my reasoning behind. And you see now, as I logged out properly, that is of course locked as well. Now, what you need to look out for when you use Kerberos with OVA, make sure you add the lockoff string, and if it has to be re-added after each update, yeah, so be it. That's something you can do with a PowerShell command. But you just need to be aware of lockoff string does not work by default or automatically when you use Kerberos. That was removed CU9 2013, so a few years back, and they have not added it since because Microsoft is forcing you to use form-based and makes it more convenient to use form-based instead. Cool, great. Wow, I'm in time. If there are no more questions, we're actually through